Okay, so we have successfully created our airfoil geometry in SolidWorks, and we've saved it as an IGES file. So now what we're going to do is we've opened up Workbench, and we're going to start a new Fluent simulation. I'm going to just name this tutorial, just for the purposes of this tutorial. Before I open the geometry, the design modeler, I'm just going to change the analysis type over here to 2D. So that's in 2D, and I'm going to open up, right click and open up Design Modeler. Wait for that to open. Okay, so we have Design Modeler open. I'm going to look at the XY plane, and I'm going to File, Import External Geometry File, and I'm going to import that. I'm going to import that IGS file. So it's this one that we want. Going to open that. So all we have to do is click Generate, and we've got our airfoil here. So the first thing we're going to do is create our domain around this airfoil. Okay, so I'm in the XY plane. I'm going to start a new sketch up here. Go to sketching. I want my domain to be a rectangle, so I'm just going to zoom out and draw a bigger rectangle as I can around the airfoil. And I'm going to dimension the upstream and downstream boundaries. I'm going to go to dimension, go to horizontal. I'm just going to dimension this distance between the airfoil and the inlet, or what will be the inlet. And I'm going to do the same for from the outlet to the leading edge of the airfoil. I'm going to do the same in the vertical sense. Dimension that. I'm going to do the same below. And finally, we're going to dimension the domain. So if we take the approximate length of our body, or the overall chord, it's going to be about 0.75 meters, as that's the bounding box we're allowed in the rules, right? So I'm just going to approximate that to 1 meter, and I want at least 8 multiples ahead and 10 behind. This number varies on what we're simulating. The aim, or what we're aiming for, is to have a domain that's large enough so that the walls of our domain do not impact upon the flow around the airfoil. So I'm just going to go with 8 and 10. So I'm going to dimension H1 as 8 meters. As you can see, that's more than enough distance. And I'm going to dimension H2 as 10 meters. Now above and below it can be a bit less, but just to be on the safe side, again, I'm just going to go with 8. So for V4, I'm going to go with 8. And for V3, I'm going to go with 8 meters. So you can see my domain is much larger than my airfoil. There's no way the walls are going to interact with the airflow around my airfoil and alter my lift and drag values. So that's that done. So what I'm going to do next now is create a surface from this sketch. So I'm going to go to concept, surfaces from sketches. And it's just sketch 1. You can see it's highlighted in yellow. Add material, generate. So now we need to perform the Boolean, and we do that so that we remove the airfoil from the domain, almost as if we're cutting out the domain. And we do that by going to create Boolean, make sure the operation is on subtract, Our target body is the domain, and what we're cutting the domain with to get our cutout the is the airfoil. So I'm just going to zoom in there. And we want to select the airfoils. So I'm just using this down here to select what's behind. So I don't want the domain. So I deselect this. I want the airfoil, right? So I'm going to select that. And you see the airfoil is selected because it's behind the domain. Very handy tool here. So click apply, 3 bodies, 3 elements, all matches. Subtract boolean. Preserve tool body should be on no. Generate. So as you can see, it's done as I wanted. What I'm going to do now is create a virtual refinement box around the airfoil so that I can concentrate a more refined mesh directly around the airfoil. This will help me to capture stagnation points and capture the correct development of the wake behind the wing. And it just allows me to be more efficient in focusing a finer mesh here instead of having a finer mesh throughout the domain. So we'll save on processing time. So again, sketching. I'm in the XY plane. I'm going to start a new sketch. Again, I'm going to go with a rectangle. Maybe if it was a different problem, you might go with a circle, but for this, a rectangle is perfect. And this time I'm going to do the same and dimension the horizontal buffer ahead. So again, taking the airfoil as about 1 meter long. As I said before, it's a rough rule of thumb. It's better to be on the safe side and have it too big than too small. I'm going to dimension the rear buffer, and then the vertical I'm going to do below and above. Okay, so I'm going to go with 2 multiples ahead. So I'm going to change this to 2 meters. I'm going to go with 3 behind. So I want this to be 3 meters. I want below to be just 1 multiple. So 1 meter. And I want above to be 2 meters, just because the wake is going to have some curvature to it. It won't just be directly behind, it will be up as well due to the geometry of the rear wing. The circulation it will introduce on the airflow will cause it to tend upwards. So I'm going to have this above as 2 meters. Oh, no, wrong one. This one here to be 2 meters. So yeah, we've got a nice little refinement box around the airfoil so we can concentrate our mesh within this region. I'll be doing some more reading so that I can get a finer or a better handle on these numbers for creating the domain. So these may be subject to change, but as long as you guys get the idea behind it, that's what's important. So again, I'm going to go to Concept and Surface from Sketch. This time it's Sketch 2, Apply, and this is an important bit, change the operation to Add Frozen. 0 thickness and generate. There we go. So that's that done. So we've got 2 parts. We've got the domain with the airfoil cutout, and then we've got the refinement box. If I hide this, this is what we've got. If I hide this and show this, this is what we've got. So hopefully you guys are able to do this. Okay, I'm just going to save that. Okay, so we're good to go for now. We're good to go to the next stage. Right, So I'm going to open up my workbench again, and we're going to head to the meshing stage. Okay, so we're in the meshing module here. The first thing that I've done is I've changed the treatment of the virtual refinement box to a construction body. So treatment here. So before it was on none, it looked like this. What I'm going to do is change the treatment to construction body to ensure that ANSYS doesn't mesh this virtual refinement box. Our use for it will be revealed later. So construction body, make sure this thickness is on 0. Sometimes ANSYS gives it 1 meter thickness for some reason. So yeah, define by geometry, change this to fluid. So if I go ahead and just generate a mesh, an initial mesh, you'll see what we get isn't the best. Yeah, not ideal. Highly skewed elements. So the first thing that we're going to do is we don't want to use these squares. We don't want to use these tetrahedrals for our mesh. We want to insert. Oh, don't want to do that. We want to insert method. Okay. So the geometry, just select the domain. We don't want quads. What we want is triangles, okay? So that's that all done. You can see we now need to update the mesh. And we'll now get triangles throughout. This is what we want. We've got some curved geometries. So we want triangles to be able to fit the mesh around the bodies without having highly skewed or twisted elements. Okay, so the next thing that we're going to do is insert a sizing, and this is where the virtual refinement box comes in handy. So what I'm going to do is, again, select the domain. I'll change the type to body of influence, and the body of influence will be the refinement box. So again, using this tool down here, select the virtual refinement box, click apply. So what that's going to do is force the size of the mesh sizing within the body of influence to adhere to this element size that we choose here. So I'm going to go with 10 millimeters, so 0.01 meters, a centimeter. Growth rate of 1.2 is fine. So now if I hit generate, you should see we have created the refinement box and refined the mesh around the airfoil. So we've got element size here of 5 centimeters within this box. I'm going to change the global sizing of the mesh. I'm going to click on mesh here. So these settings here refer to the global mesh. Obviously these, if you click on this, these settings refer to the body sizing. So back onto mesh, go to sizing. Element size up here underneath defaults. I'm just going to change this to 0.5 meters. Just to give me a better mesh in the greater domain. So you can see that's looking a lot better now. What I'm going to do next is I'm going to introduce some edge sizing around the airfoil. So insert, sizing, click there, element size. So we know the geometry we want is the edges of the airfoil. So I'm going to go to mode, box select. Just select all these edges. So it should be 9 in total, correct. I'm going to stipulate a 0.001, so a 1 millimeter edge sizing along all these edges. Yep, generate. Okay, so there's a warning down here about mesh defeaturing. So to solve that, we click on mesh again for for the global mesh settings. Go to mesh defeaturing down here and just put this onto no. Hit generate again. Okay, so that's all good. So you can see now we've got a much finer mesh at the wall, which is what we want. So before I add inflation layers, I'm just going to create some named selections, okay? So again, if I go to box select mode, and then I want to select those three, create name selection. This is going to be my main plane. There's no space there, is there? Okay, okay. So you can see I've got my main plane, 3 edges as it should be. Going to do the same for the next airfoil. Just want to get those three. Create name selection, flap 1. So again, 3 edges for flap 1. I'm going to do the same thing again for flap 2. So we've got flap 2. Main plane, flap 1 and flap 2. There we go. If I go back onto single select, so I've got main plane, 3, 3 and 3. So what we're going to do now is change the program controlled inflation setting to include these edges, right? Include, and include. So now, when we add inflation settings down here, so we want first layer thickness. So I've calculated using a calculator from Pointwise, who just Google Y plus calculator. We want an approximate Y plus around 1 for our first cell. And using the simulation conditions, so the Reynolds number, the inlet velocity, and some other things. If I just show you the calculator, here it is, Pointwise. So I've inputted the free stream velocity, desired Y plus, the reference length, which is 0.75, the density standard, and then the dynamic viscosity. I've just used the default in ANSYS for that, and it will give me the Reynolds number as well as the first cell height, this delta S. Okay, so I've copied that in. So if I copy that in to this first layer height here, now the number of layers will be dictated by whether or not we can achieve a smooth transition between the last inflation layer and the first triangular element. So I'll show you this. If I select about 10, between 8 to 20 is a good range from what I've seen and what I've done in the past, with a growth rate of 1.2 to limit numerical diffusion or errors, basically. If there's too big a discrepancy between the sizes of adjacent elements or cells, then it can introduce some errors in the CFD, and it hasn't done my inflation layers. Why has it not done that? Okay, let's just force it to. So if we go to inflation here, sorry, my bad. Okay, so select this, apply. Boundary scoping is what we need to change to name selection. So the boundaries will be main plane, flap 1, flap 2. I'm holding control to select all of them. Again, change the maximum layers to about 10, 1.2 for the growth rate. Generate, and we should have some inflation layers. Okay, yes, we've got no errors there. Okay, so we've got our inflation layers. As you can see, we've got those inflation layers there. We're still not quite there. I'm quite happy with it. So what I'm going to do is I'm going to reduce the edge sizing from 1mm to 0.5 mm. 5 mm there. Hit generate. Okay, so I think it's growing a bit quickly from around the aerofoil to the rest of the domain. So what I'm going to do is, on this edge size, I'm going to change the growth rate to 1.2. Sorry, 1.1. Just to slow the growth of the mesh elements away from the aerofoil, give us a greater area of refinement. It's a bit better. What I'm also going to do is go to mesh here. I want to capture proximity. Change the number of cells across gap to 15. Should help the mesh. I should change to 20. Should help the mesh in these areas here. Capture curvature is already on, as it should be. Okay, let's have a quick look at our skewness. What's our skewness on right now? 0.66. Yeah, that's good. That's acceptable. Not too high for the maximum skewness. You can see the average is below, pretty much 0. So if we generate that there. Okay, so let's just get rid of that. Don't care about that for now. The mesh is looking a bit better. Just going to reduce the sizing in our virtual refinement box. So the minute is on 5 centimeters. Just going to reduce that to 3. Hit generate. Okay, yeah, so you can see the effect of that box. We've got a much more refined mesh around the aerofoil. The transition from the size of this last inflation layer to the first domain triangular element is okay. There's not a huge growth. Not anywhere that I can see. Our skewness is okay. Max of 0.76, which is acceptable. And yeah, let's have a quick look at where we've got these skewed elements. Is it going to show us? Oh, so there's one up here. So you can see it's literally just the odd element. Nothing major. Yep. Okay, so what I'm going to do last but not least is change this back to none, get our mesh back. to add some more name selections. So go to my edge selection tool. I'm going to name this. You can probably guess this is going to be our inlet. I'm going to name this so our fluid flow will come in from here and exit here. So this is our outlet. These two will just be, these will be zero shear walls or slip walls. So they'll have zero normal velocity at the wall, only velocity along the wall. It's just a way of stipulating an infinite boundary condition, if you like. So walls. So we've got our main plane, flap 1, flap 2, inlet, outlet, walls, and then the interior. Okay, so we're good to go to the next stage, I believe. So we look down here, we've got 128,000 elements, which isn't too many at all. So yeah, as I said before, these sorts of mesh metrics, they may be subject to change as I do some more research. But they are sort of, they should be okay for now. Obviously, a mesh independent study remains to be done. That will help in sort of giving us some concrete figures and sizings and measurements to go for. But for now, these should suffice just to get you learning ANSYS. So we're done. I'm going to save this. We can head on to the next stage.